Good morning to all, and welcome you all for the 24th lecture on basic circuit theory. So, what we have been discussing, we started with third unit and we completed mesh and nodal analysis for AC circuits. Today, I want to start the very first theorem. Today, I want to start the very first theorem. It is superposition theorem. Yes, I'm audible.
Yes, sir.
Okay, so put the heading superposition theorem for AC circuits. So today my aim is I want to complete superposition theorem, Thevenin and Norton. Okay. Already you know what is superposition theorem. So concept wise, nothing new. But in unit 2 we played with a real number. Here we are going to play with complex. That's a difference, right? So superposition theorem. There is no space, okay, between super and position.
சார் இதுக்கு டெஃபினிஷன்ஸ் கேட்டா அதே தான் எழுதணுமா சார்?
அதேதான்பா, சேம் டெஃபினிஷன் தான், எந்த சேஞ்சும் இல்லை. சரியா? Definition is common. If it is asked in unit 2, then give some example from real numbers, okay, from DC circuit. If it is asked in unit 3, then try to give it in terms of complex number, okay, that I will let you know, you don't worry. So now I want to take in order to verify superposition theorem, as I told earlier, I want to take a problem from nodal, not from mesh, okay. So can you remember this nodal analysis problem? Last class, I think so. This problem, right? Nodal analysis problem. Can you take the same problem? Please take by yourself. Take the same problem. And here we found V1 and V2 by using nodal analysis. And my aim is this time I want to calculate V1 by using superposition principle. Okay. So take the very first problem. Use superposition to find V1 for the following circuit, and this is my circuit. So let me copy this. You guys please draw this diagram. So copy, and I am pasting it here. The question is, use superposition to compute V1. Okay. Next question, use superposition to compute V2. That you do by yourself. This is my example 1 for today's class. Okay. Guys, are you with me? How these two are connected? And what about
Parallel,
these
sir.
two? And what about these two? Right. Okay. What is this inductance value? This is J10, right? This
Plus
is,
G10, sir.
yeah, J10. Oh, okay. Now take this first parallel configuration. Okay. I want to draw the equivalent circuit diagram. I want to reduce this diagram by using network reduction. Okay. You know, if two resistance are connected in parallel, then what is the equivalent resistance, right? So now here, what is the equivalent resistance? Anyone? Take some R equivalent 1, 5 parallel with minus J10, right? So what is the formula? As usual formula, R1 int R2 divided by R1 plus R2. So what is this? Minus J50 divided by 5 minus J10. How will you find real and imaginary part for this minus J50 divided by 5 minus J10? Anyone? Any idea? I want to find the real and imaginary part, but here I am having minus J50 divided by 5 minus J.
Denominator multiply and divide பண்ணும் sir.
Then you want to take the complex conjugate. So you want to divide, multiply and divide it by complex conjugate. You know why, right? So what is the complex conjugate of 5 minus J10? It is 5 plus J10. So multiply and divide by 5 plus J10. So now what is this value? 5 minus J10 into 5 plus J10. Coming to denominator, A minus B into A plus B, nothing but A squared, okay, minus B squared, where B is J10, okay. So A squared minus B squared. Coming to numerator, 5 times minus J50 minus J250, okay, then minus J squared 500. What is this value? What is 5 squared 25 minus J squared minus becomes plus 100, okay, and this is minus J250 plus 500. So what about this value? 500 divided by 125 minus, okay, J250 divided by 125. So this is 4 minus 2J. Can I write? R equivalent 1, 4 minus 2J. This is the way to find equivalent resistance, okay, in AC. Same formula, you want to play with complex number, that's it. So now can you redraw this circuit? The same circuit actually. I want to reduce this circuit. Okay. So here I am having my AC current source, one at an angle of 0 degree. And here the impedance, since I am having 4 minus 2J, you can draw one box. Okay. And put it in this. This is the way. Okay. Now can you reduce this? J10 and minus J5 are connected in parallel. How will you this time? Anyone? Just calculate by yourself. And in case of any doubt, refer the board. Take this one is R equivalent 1 and this one is R equivalent 2 just for our reference. And take this two are connected in again parallel. Take this one is R equivalent 3. So find R equivalent 2 and R equivalent by yourself. And in case of any doubt, please refer me. So J10 and minus J5 coming to R equivalent 2. J10 parallel with minus J5. So you know R1, R2, J10 into minus J5 divided by R1 plus R2. So J10 minus J5. So it is minus J squared 500. Okay. 500 or 50? Yeah, 50.
50 sir.
Okay, 50 divided by it is J5. Okay. So now This j and j squared will be cancelled, so you will get minus j, so it is minus 10j. Yeah, right. This is also actually no. So this can be replaced by what is minus 10j? Is it capacitor or inductor? Any idea?
Capacitor, sir.
Yeah, very good. So this can be replaced by a single capacitor. You know the reason why minus 10j is capacitor, right? So you please try to understand by yourself. Okay. Then what is R equivalent 3? Anyone have you found? I think so you can find by yourself and let me know the value. R equivalent 3. And here I'm having my full and full you are going to play with your calculator. That's it. Okay. சும்மா உட்காந்துட்டு இருக்காது. Please take because you guys you don't have time, okay, to practice. At least try to use this hour, class hour itself as a practice session. Now what is R equivalent to, right? This is, and find R equivalent 3. This is 0.5 at an angle of minus 90 degree ampere. This is 1 at an angle of, this is ohm. What is R equivalent 3?
Sir, 2 plus 4j.
Okay, so this is my equivalent circuit. Now I am going to apply superposition. You guys please take note down. R equivalent 3, 2 plus 4j. So please verify by yourself. Now, okay, so coming to theorem, what it says, first when 1 at an angle of 0 degree source is active. Okay, so this time I want to kill this guy. So what you will do? Will you replace
Open
this
circuit.
open circuit? Why open circuit? Why my open circuit? Anyone? Why it has to be replaced by open circuit?
Your internal resistance.
No, my question is it current source or voltage source?
Current source.
Current
Yeah,
source.
current source. That's why you want to replace that one by okay open circuit. If it is voltage source, then you want to replace by short circuit. That concept you know, right? Okay. So now this is my equivalent circuit. Okay, I killed 0.5 at an angle of minus 90 degree. So when 1 at an angle of 0 degree source is active, okay, this is where is your V1? This is my V1 actually, right? So I want to calculate V1 here. So what is V1 with respect to ground? Okay, so this is my plus, this is my minus. So I want to calculate the voltage across this 4 minus 2J. Okay, so for your reference, I am writing here what is V1. Okay, it is the voltage across 4 minus 2J. So how will you find the voltage? Any idea?
Sir, current through 4 minus 2G கண்டுபிடிச்சு
Okay, கண்டுபிடிச்சு then you can multiply the current by this resistance, right? So V equal to I times R, where R is nothing but that 4 minus 2J. Okay, how will you find I? How these two are connected? How these two are connected?
series.
Series. So can I draw the equivalent circuit diagram once again for your reference? Okay, so let me draw that 1 at an angle of 0 degree, and this is my 4 minus 2j. Okay, so 2 plus 4j minus 10j. How much more? So it is 2 minus 6j. Okay, so this is just for your reference. Now this is my V1. Okay, so now how will you find the current resistance? Now how will you find the current which is flowing through this? Okay, can I take some I? Okay, actually this one is V1 dash, right? Means my first circuit. So let me take this one as V1 dash. So V1 dash equal to. So now what is the formula to calculate? So let me draw write the equation. V1 dash equal to V I into R, where R is 4 minus 2j. Okay, what is the formula to calculate I? I, how will you calculate? Any idea?
Current division.
Current division rule.
Yeah, thank you. So current division rule. So straight away can I write the formula? Current division rule, applied current, okay, into opposite resistance divided by total resistance. Okay, this is my I actually into R, where R equal to 4 minus 2j. So what about this one? This time I want to play with rectangular coordinates, not polar. Okay, so before writing V1 dash, I want to let you know one thing for you guys. Now take my previous class problem. Okay, take this problem, and we found V1 and V2 in polar coordinates. Now can you let me know the equivalent? Okay, in rectangular coordinates, anyone? You know how to convert polar into rectangular by using formula as well as by using calculator. Okay, do you want to give the formula? Formula சொல்லணுமா? Mathematics fundamental formula, you guys you know it. Now my question, convert V1 in terms of rectangular and let me know the value. So உங்களோட எம்எஸ்ல பார்த்தீங்கன்னா go to complex mode, shift to 2 அமுக்கிட்டு, okay, now type 2.23 at an angle of minus 63.4. அதில் பிளஸ் மைனஸ் சிம்பிளை பாரு, அதில் ரெக்டாங்குலர் போலார்ன்னு இருக்கும், பிளஸ் சிம்பிள் நினைக்கிறேன் ஃபார் rectangular. So type 2.23 at an angle of minus 63.4. Then type shift, press shift 2. I mean press shift அதுக்கப்புறம் plus symbol பண்ணி காட்டணுமா? Speak something. At x equal to r cos theta, y equal to r sin theta. So x plus jy will give you, this is my r at an angle of theta, and here you will get x plus some jy. Okay, so where x equal to r into cos theta, y equal to r into sin theta. Okay, anyone please help me, what is v1 in terms of rectangular? நீ ஆன்சர் தான் சொல்ல போறேன், நான் சொல்ல மாட்டேன். Anyone?
Sir,
Yes, are you with me?
minus
Ah,
2j, sir. 1 minus 2j.
yeah. Thank you. 1 minus 2j. What is the unit? It is volt. Similarly, what is V2? You know why I am converting this polar into rectangular? Because you want to have a practice, and as well as anga superposition I am going to play with rectangular. So I want to verify whether am I getting V1 as 1 minus 2j or not. That is my plan. Got it? Now similarly, let's take it as a practice. Convert V2 also and let me know the value.
Sir, minus 2 plus 4j, sir.
Thank you, ma. 4j volt. Okay. So please make a note. Okay. So V1, if you will find, you will get 1 minus 2j. Similarly, V2, you find by yourself. Now I want to find V1. So now what is V1 dash? Anyone? This take your calculator. What is V1 dash?
So 0.06 plus 0.08i.
Please check.
Okay.
Please check your answer. Anyone? Any other answer?
Sir, 2 root 2 at an angle of minus 45.
In terms of rectangular, can you say the
2
equivalent?
minus 2i, sir.
Yeah, very good. The answer, expected answer is actually 2 minus 2j. Okay, that's the correct answer. It is my V1 dash volt. So please. Now, what is my view? Now, when the next question, next, at this time, I want to kill this guy, 1 at an angle of 0, and I want to activate 0.5 at an angle of minus 90 degree. So this time, what is the equivalent circuit? When 0.5 at an angle of minus 90 degree source is active, you please draw the equivalent circuit. Okay, let me copy this. Yeah, paste it here. Okay, so this time I want to activate, okay, this one. So you want to replace this one by open circuit. Okay, yeah, and now this is my, take this time, this is V1 double dash. Okay, so this time, what is the formula to calculate V1 double dash? Anyone? But this time you want to be careful for your reference. Here I am drawing the equivalent circuit. How these two are connected, first of all?
Series, sir.
Series. So what is the equivalent? Can I draw like this? So it is I mean 4, okay, minus 2j minus 10, it becomes 4 minus 12j or 4 minus j12, okay. Then this is 2 plus 4j, and here the current is it is 0.5 at an angle of minus 90 degree, okay. This time what is V1 double dash? V1 double dash, that is nothing but the voltage across 4 minus 2j, okay. So the current, how will you write the, that's what I'm writing here, V1 double dash, the voltage across actually 4 minus 2j, V equal to I times R, where R is, don't change that resistance, it is 4 minus 2j into I. Let me take, this is my I, okay. Since the current is flowing in opposite direction, so applied current this time minus 0.5 at an angle of minus 90 degree into opposite resistance 2 plus 4j divided by total resistance, it becomes 4 minus 12j plus 2 plus 4j. Okay, any doubt in this formula? V equal to I times R, but here R is, okay, don't put 4 minus 12j, please keep it in mind. Don't put this 4 minus 12j here, okay. Actually, what is V1 does? As per this diagram, V1 does the voltage, okay, across 4 minus 2j. So the resistance is 4 minus 2j, not 4 minus 12j. Got my point or not? Guys,
Yes, sir.
Okay. So now what is V1 double dash? Anyone? Be careful. It is minus. Why this minus? That you know, because current is flowing in opposite direction, right? So that's all this minus. Anyone got the answer?
So -1.
Very good. Should be minus 1 volt. So finally, we found V1 double dash. And you know what is our V1? Simple algebraic sum. V1 dash plus V1 double dash. Where V1 dash 2 minus 2j. And V1 double dash, you know, minus 1. So what is this? 1 minus 2j volt. And please verify this answer with our previous nodal analysis. Have we got V1 as 1 minus 2j or not? Okay. So last class we solved the same problem by using nodal. Okay, just now we converted this one, right? We got V1 as 1 minus 2j. Okay. So the same expression here I have got. So that's why I converted that polar into rectangle. So this is the way to apply superposition. Any doubt? So concept, nothing new, but here we are playing with what is that? Complex number. That is the difference. Okay. So I will give you one more problem as homework at the end of this class. Now I want to move to where? Thevenin and Norton's theorem. Okay. Have you taken this? Now take the same problem. Now put the heading Thevenin's and Norton's theorem for AC circuits. Thevenin's take the same problem. This time determine Thevenin's equivalent circuit seen by minus J10 ohm. Example 2 for today's class. Okay. I want to solve one more problem for Norton's. So today I want to solve 3 problems. So determine Thevenin's equivalent circuit. Okay, seen by this time minus J10 ohm. So this time this minus J10 ohm will act as your load. Okay. Can you recall the procedure? First of all, take this problem and let me know. Then I will move. And parallelly, please recall the procedure, okay, to calculate VTH as well as RTH. Okay. And mostly here they won't give a dependent source. As we discussed, okay, in unit 2, you are having 3 cases in Thevenin and Norton. Case 1, all are independent sources. Case 2, at least one dependent source along with n number of independent sources. Case 3, all are dependent sources. Ella now oruka? Can you remember all these things? Okay. Now coming to case 1, because it's false. Okay. Under case 1, here I am having two independent current source. So all are independent sources. So at that time, how will you find VTH? Anyone? What is the procedure to calculate VTH in case 1? Anyone? Procedure to calculate VTH. So first, I want to calculate VTH. Subdivision A to calculate VThevenin. Procedure to calculate VTH. Anyone, can you help me? I forgot the method. Please help me. Witness, are you there? Sound a gun. What is the procedure to calculate VTH?
So open the load and find the voltage across it.
So very first point, you want to open the load. Yeah, thank you, ma. Open the load. And second point, find, okay, open circuit voltage actually across the load. So this time, what you will do? You will open this load. Okay, just listen me. I'm opening this whole load. Okay, and now, you know, this is my VTH, right? VTH. So this is my plus and this is my minus. Okay. Now how will you find this VTH? It's quite interesting. Any idea? And what is this? What is this? What is this?
வோல்டேஜ்
Practical current source.
This is a very good practical current source. Okay. Convert this one into practical voltage source. Just time being, okay, I'm drawing the equivalent like this for your reference. Okay. So here actually we will have one. What about this? What about this voltage value? Okay. And coming here, not about this voltage. Okay. This is also another practical current source. You can convert this current into voltage. Now the polarity is very important for me. Is it minus 2 plus or plus 2 minus? Coming here, the first one, pink color la round பண்ணிருக்கேன்ல. You know the source transformation theorem. According to my logic, the arrow mark indicates positive or negative. Positive. So this is my negative. Time being, take this is some VA. Okay. And this is my VTH plus minus. Okay. And coming here. Now what will happen here? This is my, this time voltage source. This value we will find later, VB. Take it as VB. So this time, is it minus 2 plus or plus 2 minus? So as per my direction, this arrow indicates positive. So this is my positive. So this is my negative. Okay. So now how to find VTH? In order to calculate VTH, just apply KVL. Apply KVL. Okay. It is minus 2 plus, so minus VA plus 2 minus, so plus VTH minus 2 plus, so minus VB equals 0. Okay, I'm looking for VTH, nothing but VA plus VB. Okay, therefore, what is my VTH? What is VA? What is VA? I'm coming here, right? Coming here, V equal to I times R, where I equal to 1 at an angle of 0. So 1 at an angle of 0 times R equal to 4 minus 2J. This is my VA plus what is my VB? VB where I equal to 0.5 at an angle of minus 90 degree, okay, into R 2 plus 4j. So what is this? It's very simple. This is your VTH actually. And calculate this value. Okay, let me know in terms of rectangular coordinates. So 1 at an angle of 0, 4 minus 2j plus 0.5 at an angle of minus 90 into 2 plus 4j.
ஒரு B வந்து 2 minus I4.
No, I am asking, I need the full answer. I mean, I want to get the answer for VTH. Straight away give me the VTH value. Just put this expression in your calculator, okay? In single step, it will give you the answer. More practice is needed, okay? And I could never put முடிச்சிருப்பேன் இந்த sum. The thing is I practiced, okay? But first time, அதான் சொல்றேன், daily use your calculator. Next or 2 to 3 classes, I will take only unit 3. Okay, I want to solve at least 1 or 2 problems for all theorems. Okay, so most probably in the week another 2 classes, and next week or 1 or 2 class I will take unit 3 only till your internal 3. After that I want to take unit 5, not unit 4. Okay, and unit 4 now on the flipped classroom, I will record all the session and send it to you and take it as a self study. You don't worry, I will record, okay, like this. நானா உட்காந்து எடுத்து ரெக்கார்ட் பண்ணி அனுப்பிச்சிடுறேன். You please refer by yourself. Okay, and save it in my drive and I will give you the link to you people. You don't worry. Self நீயா படிக்கணும் அப்படின்னா யோசிக்காத. சொல்லுமா.
6 minus 3j.
Yeah, very good, very good. So it's 6 minus 3j. What's the unit?
Volt, sir.
Yeah, volt. So this is the way to calculate VTH. Okay, it's very simple. So using source transformation and the KVL. That's it. Nothing new. Now coming to RTH. Okay, subdivision B to calculate RTH. To calculate RTH. Can you recall the procedure to calculate RTH? We will start from scratch, no problem. Let me paste the circuit diagram. Yeah, this is my original diagram. So what is the procedure to calculate RTH? Anyone? First point, you want to open the
Independent sources will be replaced by their internal resistance.
Yeah, very good. So replace. Okay, simply I am writing voltage source by short circuit, current source by open circuit. So now open the load. Okay, yeah, sorry. Open the load. I opened. Okay, yeah, and replace this guy current source by open circuit. Okay, here also open circuit. Okay, so now what is remaining? And this is my RTH. How these two are connected?
Parallel.
Parallel. Listen carefully. Series. See, this is my take, this is my time being take, this is A, this is B. Okay, how these two are connected? See, how many? Only one terminal is connected, right? So series. So it's very simple. Therefore, RTH equals 4 minus 2J in series with 2 plus 4J. So it is 6 plus 2J, correct? The unit is 1. This is my RTH. That's it. Suppose for the same problem, if you will calculate IN, how will you calculate IN? without using the procedure. I equal to V by R. This is VTH divided by RTH. You found VTH and RTH. Take the ratio, and that is the way to find Norton's theorem. In that way also you can find nothing wrong. Okay. So my final problem for today's class. So example 2 Purunchama, for the same nodal problem. Okay. I used the same problem. Okay, for superposition as well as Thevenin. And this time I want to go for one more problem for Thevenin and one more problem for superposition also. For superposition, I will leave it to you people. Take it as a homework problem. Just to sit and work on it. I will give the final answer. I will forward my material for this. Okay. இப்பவே அனுப்பிச்சிட்டேன்னா ஆன்சரை பார்த்து சொன்னு சொல்லிடுவேன். அதனால அனுப்பாம வச்சிருக்கேன். You don't worry, I will forward the required material for unit 3 also. When is last working day? As of now, it is October 25th. And when is your internal 3? Internal 3.
22, 23, 24.
You know the test pattern this time?
Proctor test சொன்னாங்க சார்.
Yeah. So be ready. Simple MCQs only. I will give you enough question banks, so don't worry. Okay? And I will guide you and I will be with you. Don't worry. Don't panic and
சார் ரிட்டர்ன் இல்லையா சார்? எம்சிக்யூ மட்டும் தான் சார்.
ரிட்டன் எப்படிமா இதுல வைக்க முடியும்? ஆனா இப்ப ஆக்சுவலா
எதுவுமே சொல்ல சார், வெறும் ப்ராக்டட் மட்டும் தான் சொன்னாங்க சார்.
அதுதான்மா. அது ஆக்சுவலா இது எதுக்கு இதை கொண்டு வர்றாங்க அப்படின்னா, சப்போஸ் இந்த செமஸ்டர் வந்து மேபி ஆன்லைன்ல இருக்கலாம். இப்போ உங்க சீனியர்ஸ்க்கு இருந்துச்சு பார்த்தியா, அனாலிஸ்ட் என்ன பண்ணாங்க ஃபைனல் செமஸ்டருக்கு ப்ரீவியஸ் இயர் உங்க சீனியர்ஸ்க்கு அந்த மாதிரி உங்களுக்கு வைக்கிறதுக்கான ஒரு பாசிபிலிட்டிஸ் இருக்கலாம். அதனால உங்களை வந்து ப்ராக்டிஸ் பண்றாங்க. ஸோ அதில் வந்துட்டு ரிட்டர்ன்லாம் எனக்கு தெரிஞ்சு கொண்டு போக முடியாது. ஒன்லி எம்சிக்யூஸ் தான் இருக்கும். இட் இஸ் மை பர்சனல் திங். ஓகே, டோன்ட் டேக் இட் அஸ் அன் அஃபிஷியல் ஒன். யூ ப்ளீஸ் வெயிட் ஃபார் த அஃபிஷியல் ஒன். பட் இப்படி தான் மோஸ்ட்லி இருக்கும். நான் கேள்விப்பட்ட வரைக்கும் தான் எம்சிக்யூஸ் மட்டும்தான் இருக்கும். ஒரு 20 எம்சிக்யூஸ் அந்த மாதிரி இருக்கும் ஈச் சப்ஜெக்ட். ஓகே, ஸோ ரிகார்டிங் எம்சிக்யூஸ் என்றால் த கன்சர்ன் ஃபேக்கல்டி தே வில் give enough question bank to you people. You don't worry. Okay, that is the instruction actually has been given to us. Very soon. Okay, you will get the information from your department. Okay, அதனால எம்சிக்யூஸ் மட்டும் தான் இருக்கும். டோன்ட் வெரி. ரிட்டர்ன்லாம் பண்ண முடியாதுமா. So can I move to the third problem? What's the time?
9:50 sir.
Oh, okay. We will solve third problem. Simple problem. Find Thevenin and Norton equivalent. Okay, for the following circuit. Example number 3. Find Thevenin and Norton's equivalent for the following circuit. Okay, the circuit is a simple circuit. Once I can take this time 3 at an angle of 30 degree. Take independent current source 3 at an angle of 30 degree ampere. Okay, in parallel with minus J5 ohm on capacitor, impedance minus J5, and in parallel with one resistance, in series with one inductor combination. Take this is my load is opened. Take this terminal AB, and this is my 10 ohm. This is my J5. So this time it's very simple. Okay, once the previous problem is understood, and then this problem is very easy. Can I move? Shall we solve? Have you taken this problem? to find VTH. Okay, this time you know the procedure. You want to open the load. Yeah, load is open and find the voltage across it. Okay, therefore, what is my VTH? The voltage across 10 plus J5. Okay, these two are connected in series. So the voltage across, okay, this series combination is your VTH. Yeah, very good. So this time, what is the formula? V equal to I times R. Okay, where I is my applied current. Okay, it is divided through minus J5 and this 10 plus J5. So my applied current is, as per current division rule, 3 at an angle of 30 degree. Okay, into opposite resistance minus J5 divided by total resistance minus J5 plus 10 plus J5. Okay, this is my I into R, where R is 10 plus J5. Okay, see, this is my sorry, this is my I. Okay, and this is my R. Okay, this I by using current division rule, R by using straight formula. So V equal to I times R. I by using current division rule that you know. So now what is this VTH? They're very simple, right? So let me know the value for VTH. Take it as a practice session. There is no other way. That's what I'm giving this much time to you people. Okay, for each and every answers. Okay, I think so. I am waiting, right? And I'm giving enough time to you people. You please just take your calculator. வழக்கமாக ஒரு 3 பேர் மட்டும்தான் ஆன்சர் சொல்லிட்டு இருக்கேன். ப்ளீஸ் ஓகே ஆன்சர் சொல்லாட்டியும் பரவாயில்ல உட்காந்து அட்லீஸ்ட் கிளாஸ் முடிச்சதுக்கு அப்புறமா உட்காந்து திரும்ப வந்து ஒன் டைம் just use your calculator. Internal 3 full and full MCQ அப்படின்னா then you want to use, there is no other way. This time you cannot copy, okay, that story and all. I don't want to enter into that situation and all. அதை பற்றிலாம் நான் பேச விரும்பல. So you please take care, okay. What's VTH, anyone?
So approximately 14 minus 9J.
In terms of this time polar, I'm not rectangular into polar.
Okay, so one second.
Sir, 16.77 at an angle of minus 33.4.
4 degree unit volt, right? Yeah, very good, correct. Next, what I want to calculate? Since I want to calculate both Thevenin and Norton, so this time I want to find, okay, IN, to find Norton current. So what is the procedure to calculate Norton? That you know, okay, this time you want to open the load is open, but you want to make a short circuit. Okay, if this is short circuit and you want to calculate this current, okay, through the short circuit. Okay, so now if it is short circuited, what will happen to this guy? What will happen? What is this?
No current will flow.
Yeah, this is actually 10 plus J5 parallel with 0. So what is the equivalent? 0. Okay, or as per he said, no current. So this, now what will happen to this guy? This is also parallel with 0. So this is also okay. Therefore, what is my IN? Very simple. IN equal to 3 at an angle of 30 degree. Please let me know in terms of rectangular. Got the point. The power rectangular மாத்திரதெல்லாம் பிரச்சனை இல்லை, but the concept is very important. When you are making a short circuit, since this is parallel, so anything parallel with 0 will give you 0, will give you short circuit. So this time, okay, my what is this? IN equal to 3 at an angle of 30 degree. I hope so you enjoyed this circuit, right? So let me know the value for IN in terms of rectangular form.
Sir, 2.5. 2.6 plus
Can I take?
1.5, sir.
Yeah, very good. Unit is very important. Okay. And this time, how will you find RTH? Anyone? So next, I want to calculate. Sorry, ma.
Sir, VTH by IN both are.
Yeah, that you know, but this time I don't. Yeah, that's correct. Okay, you please do that. That is one method. Or another method, what is the procedure to calculate RTH? Old circuit. So I don't want to now take. Let me take this circuit. Yeah. Let me draw one more time. Nothing wrong. T at an angle of 30 degree ampere. Okay. Here I'm having one capacitor. The value is minus J5 ohm, and I am having one resistor in series with this guy J5 ohm, and this is my 10 ohm, right? Yeah. Okay, this is my load. Yeah, load is open. So you know the procedure, right? First we will calculate as per procedure, then later you verify, okay, by using this formula. You know, R equal to V by I. You calculated VTH as well as IN, that will give you RTH. Okay,
Sir,
this is one
correct,
way.
sir.
Yeah. So you want to open the load, so load is open. Okay, and you want to replace current source by open circuit. Yeah, I'm replacing current by open. Okay, so now what is my RTH? Anyone can help me? Therefore RTH equals, yeah, this minus J5 in parallel with, okay, 10 plus J5. What about this one? R1 R2, right? So 10 plus J5 times minus J5 divided by R1 plus R2. So 10 plus J5 minus J5. What about this value? So these two will be cancelled. So you will end up with 10 in denominator. So this is 10 plus J5 minus J5. So it becomes minus J50 minus J square 25. Okay. So what is this? Minus J50 by 10 plus 25 divided by 10. It will give you 2.5 minus H. We got this.
Yes, sir.
Okay, now do one thing. You by using this formula, please verify. What's the time? Yeah, the time is almost done. I will give that homework problem alone. Then I will leave it. You guys please verify this RTH by this taking this ratio VTH divided by IN. You will get the same RTH. Please verify are you getting it or not. Okay. So now take my homework problem. Okay. Use superposition. Okay, to find I. Use superposition to find I. Okay. So the given circuit, you know, this is 3 cos 2t volt, and this is 4 cos 5t volt. This is, I think so, 3 Henry, 1 Henry. and this is 4 ohm, and this is my I actually. And you want to calculate this I, okay, which is flowing through 4 ohm by using superposition. Actually, this time this is my time domain, right? ஒரே ஒரு ட்விஸ்ட் மட்டும் இருக்கு. அது என்னன்னு anyone can you guess? That twist alone, okay? I will let you know. Then remaining is very simple. What is the twist? Any guess? Okay. And you know how to convert time domain into frequency domain. Okay. Can you recall that? So corresponding frequency domain circuit. Frequency domain circuit. Okay. So frequency domain என்ன பண்ணுவீங்க? So you will sketch this plus minus. What about this value? 3 cos 2t in terms of polar form. How will you write?
3
It
at
is
an angle of
3 at an angle of 0 degree volt, right? Yeah, okay. Then you are having this inductor. You want to find the reactance offered by the inductor and the resistance, no problem. Already it is in ohm, so no need to worry. So here you will give 1 Henry. Here also you want to find reactance. Okay. And this is my plus minus. What about this one? 4 at an angle of 0 degree volt. Okay. Okay. Now this is my 3 Henry. What is the reactance offered by this 3 Henry? What's the formula? J
JL
omega, where J is imaginary number. Okay, L 3,
3
omega 2 pi f, or omega is given. So see, what is omega? Here this omega it is 2,
sir.
but here you are having one more omega, it is 5. So
5.
which value? So what you want to do? Very first circuit, what you will do? When, yeah, this 3 at an angle of 0 degree is active. Okay, at the time what you will do? You will replace this by
Open
short
circuit.
circuit, right?
Short circuit.
Short circuit, right? Short circuit. So now what is my omega? Omega equal to 2.
Sir.
So it becomes 6J. So be careful. So 6J. What about this one? What about this guy? 1 Henry. What is the reactance offered by 1 Henry?
2J, sir.
JL omega J, where L is 1 omega. So very good, 2J. So it is 2J ohm, right? 6J ohm. Now find this. Let me take this in as I1 dash, right? And you know how to find I1 dash by using simple mesh analysis. Just to find by yourself. And subdivision 2, this time when this is 3 at an angle of 0, or if you want to write 3 cos 2t, nothing wrong. Okay, when 3 cos 2t is active. So this time I want to kill 3 cos 2t and I want to activate 4 cos 5t. So when 4 cos 5t is active, so this time what is the equivalent? Can you draw by yourself? So this I will replace by short circuit. Here I am having one inductor, then this resistor, then this inductor. Okay, so this time here I am having my independent AC voltage source. This value is 4 at an angle of 0 degree. But this time what is my omega? Omega equal to 5. Omega equals 5. So this is my 4 ohm. Let me take, this is my I1 or I double dash. Okay. Now this time what is the impedance reactance offered by 3 Henry? 3 times 5. What's the value? 3 Henry. This is 1 Henry. What is the reactance offered by this 3 Henry? According
15J
to
and
this.
3J, sir.
Thank you. 15J ohm. Here it is 5J. Okay. So this time find I1 dash. Therefore my final I is given by I1 dash plus I1 double dash. Okay. So please note down the answer. If you will calculate, you will get 175.6 I'm writing in terms of time domain. You please find frequency, then convert into time. So cos, this is 2t minus 20.55 degree plus 547.1, okay, cos 5t minus 43.16 unit sample. Please make a note. Therefore, what is your I dash, right? Not I1 dash, it is I dash. I dash, I double dash. Can you say in terms of polar from the given answer? What is I dash in terms of polar?
Sir, 175.6 at an angle of minus 20.35.
Minus 20 points is 551.
5 phase.
If my letters are not legible, if it is not clear, please let me know. Okay. 547.1 at an angle of minus 43.16 degree ampere. Okay, if you will calculate in terms of polar, you will get this. So this is my frequency. Okay, and you know how to convert this frequency into time domain. Okay, this is my frequency domain, this is my time domain.
சரி, இப்போ ஆன்சர்ஸ் வந்து எல்லாமே போலாரில் எழுதணுமா இல்லை ரெக்டாங்குலரில் எழுதணுமா, எப்படி
It's
எழுதணும்
up to you, nothing wrong. Okay, anything you can follow, no problem.
ஓகே சார்.
If it is not mentioned, okay, sometimes it is possible. Okay, suppose let me ask a question like this. Okay, find I1 in terms of rectangular form. At the time you want to write I1, okay, in terms of rectangular form. Or sometimes the question, okay, it is given the circuit in terms of time domain. Then finally you want to write the answer also in time domain. That's the best practice. Suppose the question it is given in frequency domain, then write the answer in frequency domain at that time, rectangular or polar. Okay, if it is mentioned, please follow that. Suppose they have given frequency domain circuit and they are asking I1, just it is given, assume calculate I1, that's it. So at that time either you can go with rectangular or polar. Best practice, please write your answer in both the format. Why this confusion? It don't take more than 1 minute, okay, to convert rectangular into polar and polar into rectangular. So if anything is not given, please write both the answers at the final step. Final, suppose this is my polar, okay, just write convert polar to rectangular and try to give in both the way, okay, in frequency domain. And time domain there is no other way, this is only one method, okay. So go with both the method. Akshay Kumar got my point.
ஓகே சார்.
ஏன்னா ஃபைனல் ஸ்டெப்ல வந்துட்டு அது don't take more than 1 minute, okay. Suppose if it is given calculate I1 in terms of rectangular form, at that time please go with rectangular form alone. Suppose if it is asked calculate I1 in terms of polar form, at that time please go with polar form alone. Okay, if anything is not mentioned, please write, okay, answer in both the format, rectangular as well as polar. That's the best practice. So any doubt? Any doubt, ma?
நோ சார்.
Okay, ma. Thank you. So thanks for your attention. We stop the recording. So those who are having doubts, okay, you can stay, and others you may leave. Thank you.